Myself Ashish K. I am working under the supervision of Professor Ashish K and Professor Rajiv Gupta. Today I will deliver my talk, not more talk, is a experience with refinement. In the last lectures, you have got lot of information about structure and how to get the XRD machine. Suppose you have an X-ray data. A lot of information is behind the X-ray data. Background, reflection. Most of times users taking the data from the operator and the operator gives the data with background correction. If you are really interested in refinement, don't do the background correction. Take the data as such as you can. The background comes out from the sample and also comes out from the scattering from sample holder, air, etc. And reflection have position, intensity, profile. Profile have a full width, half maxima, peak shape. It may be in a Gaussian, Lorentzian or a mixed shape. It's called pseudo-white. Position is related to the lattice parameter, space group. Intensity is crystal structure. In the last class, Professor Ashish Garg sir told a lot of things. And the profile is the full width, half maxima. The shape of your peak, you should to aware about from the instrumental broadening also. And you should to know what is your instrumental broadening. Take some standard sample like silicon disc or silicon and do the scan in the overall range 20 or 10 to 120 and see and what is your instrumental broadening and just separate from your data. Sample broadening is the real structure of your sample. Limitations of the experiment. A good XRD fitting and a successful retrial analysis depend strongly on the quality of the experiment. Instruments. First, what you choose. In last lectures, you know the Loup method, rotating crystal method or powder method. What is your requirement you should to know. Second is instrument characteristic and assignment. Most of times people did without the instruments errors, like suppose you did the XRD and instrument already have some residues in 2 theta and omega, as told in last lecture. 2 theta and omega are the coplanars. So you should to scan the 2 theta and omega in direct scan mode, and it will I will show you. In 2 theta scan mode, the peaks will comes as like, and suppose it should be comes out be 0 and it is not comes out on the 0, like it shifted be as like, then you should to center this position. That much will be comes out 2 theta error, some values will comes. Then again do the scan, omega scan. It will tells about your sample is flat or not. It is a sample requirement. And suppose you have a flat sample, so you should to do the omega scan. It will tells sample is be flat or not, in what region. And suppose it comes out as like, the highest will peak will tells in this region the sample is mostly flat. This omega will give some value. Then in the software takes suppose it as a 0, this value, that it will not be include in your data because you already suppose this be 0, and then take the data from the machine. Collection strategy, range. The person already told in last lecture what is the importance of 120. The requirement in refinement is should to take a long range, at least 20 to 80 or 10 to 90. And the higher range is also having a one importance respective to your material. Step size. Step size mostly probably is chosen 0.02 to 0.05. What is the importance of step size? If suppose your two peaks are very narrow, and you took the step size more, what will happen? The two peaks will merge and it will give a broad peak. The broadening will comes. So you should to take as least as your possible, at least 0.02 to 0.05. Third is collection time. What is your speed of collection the data, and etc. Sample requirement. What type of sample you are taking? Suppose you are taking the crystalline or polycrystalline sample, amorphous sample, or amorphous with crystallinity. Most of times polycrystalline sample have a flat background, but in amorphous or amorphous with crystallinity it will gives a hump. So don't subtract the background, because I already told background having a one importance. Suppose you have the XRD data in your hand. First you will check this is in pure phase or not. The JCPDS database and ICDD, you can check from these two databases. This is your be in pure phase or not, how much be is matched with your reference data. Reference data is nothing, it's already be published previously. Then if you sure you have in a pure phase, then do the indexing, and then you are ready for refinement. In Rietveld refinement, this most of information you already collected by Professor Ashish K. I will just say this Rietveld refinement is devised by Hugo Rietveld for crystalline materials, and least square approach is used to minimize the function. M is summation I Wi yi observed. Yi observed is the observed intensity, and yi calculated is the calculated or modulated intensity. Wi is the statistical weight factor, is nothing, is inversely square root of yi observed. If the scale factor both are y observed in the last, C into yi observed is yi calculated, it means totally perfectly fit. These are the useful softwares. No sir. Okay. These are the useful softwares. You can refine your XRD data. Expert high score plus. You can refine, you can indexing, all things you can do. CSAS, it's a paid software. Retain is also paid software. Mod program and Foolproof. Foolproof is a free software, and this Foolproof software comes in existence with the Professor J.R. Carvajal. Is a French scientist and French professor, you can say. Suppose you have an XRD data, you did the indexing, and you also know what is the space group because you already have in a database, and you also check from this Wilbau crystallographic server. It's a very what can I say, it's a very good software. It's not a software, it is a database, and you can see here what is your space group, what is your matrix, what is your Wyckoff position, a lot of information is here. Suppose the subgroup is changed, so you can change according to previous subgroup. It's having a lot of facilities here, and it's also free. And the second is space group diagram and tables for your information, what like space group in figure form. Yes, sir.
So if I have access to this, you are telling is free. So I don't really need the ICDD database, is it? Like means if this is available on the net for free, I don't really need the ICDD database.
Sir, PDF2, PDF4 is the database now in expert high score.
No, but we pay for it. So
Yes, sir. Yes, sir.
can I avoid it? Like what you are saying that it is available for free?
Sir, free is not here. Sir, for indexing the data is not free. Foolproof is just for refining the data. Yes, sir.
What about match?
Match is also here, but it's not free.
Which is free?
Foolproof. Mode, I don't know about sir mode, but most commercially used is foolproof, or now I will tell just about foolproof. This is the foolproof program. Just this is a snapshots. How will you go further and further? So I will be here just to show, and after that I will run a program. First, click the EDPCR file. Then that window will open, and they click here for the new data. All are be inactive be here. If you will click be here, the all will be highlighted. Then click the general. Then that window will open. Put the sample name be here. Then the second one is pattern. It will be downward one by one. Then pattern. Then that window will open. This is a data file and peak shape. That window will open, and format is dat format. You should to first make the dat file from your XRD data, and the file format is 2 theta starting, then step, then 2 theta final value, then enter and paste the all intensity value, and the save as .dat format. If this file will be generated, then upload be here. Then refinement and simulation, X-rays and pattern calculation X-rays. If you will click be here, the all profile data will be simulated, and if you will click here, then you will be do manually. What is your wavelength of X-ray target, like copper, cobalt, according to respective, the wavelength will comes out be here. It's already be included here, but suppose if you are using with some wavelength, you are not be here, so you can be used be here user define and put your be wavelength here and here and the intensity ratio. Then last one is pattern calculation peak shape here. I already told this X-ray peak may be Lorentzian or Gaussian combination. So we are taking the pseudo white, it is a combination of Lorentzian plus Gaussian, like y is equal to a b plus a 1 minus a c. Put the value of 2 theta minimum in dat file format and maximum step size. Then the pattern information, background. If you are talking about the polycrystalline sample, that sample who have a linear background, then you use the 6 coefficient polynomial function. And suppose like some amorphous, due to amorphous nature, you have some slopy background, so you will use the linear interpolation between a set background point with refinable heights. That is why I told about the background importance. Then the phase information. Name of the phase you should to write for sake of your knowledge. Orthorhombic, like here, it having a lot of option here, but for refining the lattice parameters and atomic positions, the option is structural model, Rietveld method. Some persons are not interested in atomic positions, he just want to the lattice parameters. So that option is with constant scale factor. Then the contribution information, X-rays, select the pseudo white, symmetry, space group, you should to know what is this sub space group of your material. Then how will you write this space group? Here is PNMA. The pattern is you should to write P space N space M space A. Suppose this group is PC21N. So how will you write? P C 21 without space. Most of times persons are doing the wrong thing here. And then N. Suppose it's be R3 bar C. R minus 3 without space and then C. And then click the symmetry operation automatic. Then the symmetry operation will becomes out be here. But sometimes be problem here, it will gives us anything. It may be some, then you should to check from Bilbao's database with Wyckoff position and symmetry operation and match it. Is there be same or not? Bilbao. That one. You can write website here. It's a very important for it having a lot of information. You can't be think now here. For Raman, for X-rays, for texture, for strain. Now I don't remember, but it having a lot of information. And most of scientists we follow this server. Okay, I will be here. Then symmetry is here. Okay. Then now you are ready for refinement. Then put the cycle of refinements, the background, atoms, profiles, all will be highlighted here. First you start from the background. I took the background 6 coefficient polynomial A0 to A5. Refine one by one, A0, then A1, then A2, then A3, A4, A5, then take a combination and then all. Yes.
How will you select the cycles of refinement?
At least 5 you can select, but you can select is not a limit. You can select 100.
So what will
But I will prefer only 5.
if I select 2 and again
So it will be it will do 2 cycles only.
so which one is better?
5 is a very good number.
This background polynomial, what is the philosophy by selecting 1, 2 or combination?
Yes, sir.
What is the philosophy behind selecting background polynomial?
For linear backgrounds are almost very some degree 0.2 to 0.25 degree,
It should be linear.
almost linear, but it having a limitation 0.25 degrees. But if in a slopy nature, then I already told for linear uh, this is yes, that linear interpolation between a set of background points, and that point will be select on that time.
What is the meaning of this 12 coefficient of Fourier cosine?
It's a relation sum, and some constant parameters will be there. Just put, actually mathematics I will not be so here.
See what happened, the people doing the refinement video,
Hmm.
then they can use the 12 coefficient of Fourier cosine.
That
That time they use this coefficient of 12 coefficient Fourier cosine. If you see in the YouTube video,
yes sir.
that time they use this 12 coefficient Fourier cosine.
12 coefficient polynomial function is means the number of points will increase at the background. Like that, suppose I put just 6 point here, and you want to more, that's a 12 polynomial function. In I don't know, in origin also having a background correction, and it's depends on you how many points you are taking. Then here, then next the refine the scale. It will refine the intensity. In simple meaning, it will scaling the intensity of your modulated to the observed value. Then refine the A, B, C, and alpha, beta, gamma you can refine if it will be your according to your structure, like monoclinic or triclinic types, where the angle also varied. Then the full width half maxima parameter, you means the u, v, w are related with the full width half maxima square here. The condition is v is always be negative here. So during the operation of refinement or after the refinement, you should to check this is negative or not. Sometimes what happen, your refinement will be complete, chi square will be minimum, but that factor is not negative, it may be negative here and here. So this software is telling this is not a good fit, and the information may be or maybe not good, maybe not right. So you should to remember the v values always be negative here. Shape parameter eta and x, it's also to the pseudo white function related, and all I would like to mention here, all parameters should be less than 1. It's a black box. If you will refine and you are thinking it comes out with 2 or 3, 4, so it doesn't meaning be here, having some limitations, it's always be less than 1. Then they refine the atomic positions. Here you can write not a tool here, like here YCRO3, yttrium, chromium, oxygen, and the occupancy yttrium is 1, chromium is 1, O3, oxygen is 3. The CRO6 case be here, 4 oxygen in the plane and 2 oxygen in the PEX. Then the ratio is 1:2. Then the occupancy is 1 and 2. Total element is 5. YCRO3 1 1 3 is 5. Yes.
Occupancy is 1, 2, 2.
Yes sir.
Occupancy how select your 1, 2, 2.
Actually here if you have a new structure, then I can't say anything now. The total element is 5 here. 1 1 3. 1 is okay, chromium, oxygen is 3 here. Then it have a possibility 1 1 1 or 1 2. Then from the previous literature they already shows there are 2 types of oxygen only, and the case is CRO6, like means 4 oxygen is in the plane and 2 oxygen in the, if chromium is here. is like. Then the ratio is of oxygen 2 into 4 is 1:2, and you can search a different way, maybe it will be good for you and me also.
Some other people are doing some different ways. They have selected 4 compositions as 6, then they divided by occupancy level Y is 1/6, chromium 1/6, for oxygen for oxygen 1/5, 1/5, 3/5. That's why they are doing something.
It appears a bit counterintuitive, no? That your occupancy is twice. I mean, I used to feel that occupancy can be 1 or it can be a fraction.
Not a fractions. It can be fraction. It can be fraction. It can be fraction. Suppose you did the doping of 30% of calcium. The occupancy is 0.7, 0.3. But that XYZ position will not change. B is the thermal factor. Yes? Yeah, you also refine this parameter also. Its unit is angstrom square.
For stoichiometric compound.
Yes.
For stoichiometric compound, if it take Wustet, then that Fe and oxygen ratio is varying. So I will take the occupancy of that compound.
Actually, I don't know the exact method of calculating the occupancy. I took also from the previous literatures.
By using Vico position, we calculate occupancy.
I don't know how to calculate.
Because we are managing it in fractions, na? So we use multiplicity factor along with Vico position to calculate.
No, this is the same thing. Na?
If the ratio is varying, if the ratio of iron and oxygen is varying,
Yes, we just multiply it.
Vico position is actually related to your space group, just. And space group can be same for lot of materials.
So it is we decide where our atrium is there.
I will not be correlate from Vico position to be directly here to calculate for calculation point of view. Then you save the data, then click that icon and save this data in the same place where you save your date file, otherwise it will not run. And one more thing, save in the format of .pcr. Save in the form of .pcr. And clicking of this icon, the refinement will start. There are this sequence to varying the parameters. Scale factor, that will scaling the intensity, background instrumental parameters, then lattice parameters, and then take the combination of backgrounds, then atomic positions one by one and very carefully, peak shape parameters, then atomic occupancy if you need, if you think. Suppose in if you are taking that material like GFO3, where the gallium and iron can be mixed, can be go on the iron side and gallium can go to the iron side and iron can go to the gallium side. Then on that time you can check the atomic occupancy after changing. Then B, thermal parameters, and if you need, then microstructural parameter like strain. This is the one of the image of after refinement. After refinement, this is the chi-square, this is the RP, this is the weighted RP, and this is the R experimental value. And the chi-square is depends on the RP and RXP ratios. Now you have all things, lattice parameters, atomic positions in correct way refined values of lattice parameters and atomic positions of your materials. Then you can ready to generate your structure. But before that, these are the some mathematical equations, more correctly the algebraic mathematics, and all equations are taken from the manual of foolproof software, not a hidden anything here. Then, yes sir.
See this fitting parameter, like it's like you are trying to find, there are many local minima, and then there is a global minima. So in today's morning lecture, Professor Ungar told that like you are doing Rietveld refinement to refine the structure.
Yes sir.
So he is involved in looking at line profile analysis. So but it's very similar. He tries to fit in the profile. So there he mentioned that now to get the global minima, they are looking at Monte Carlo plus their minimization of the tax.
Monte Carlo is a simulation software, na sir?
No. That's but you can also use it for
Okay.
minimizing. So is there a extent, because you have
Sir, for that I don't have knowledge. Or sir, sorry if I didn't attend the class.
because, I learned this today morning. only,
Yes,
that
sir.
It seems like because there we have like 5 or 6 unknown parameters. Here you have so many unknowns, right?
Yes sir.
And the way you refine, if I get it correctly, is that you keep quite a few things fixed and then
This is totally manually.
so that's what you do. I was just wondering like whether
But it's a very good thing, all things be in your hand. Then you are ready to generate your structure. One more software is Vesta, it's also free. It's a very easy way to generate your structure. From structure, you can get a lot of information like bond length, bond angle, distortion index, average bond length, and you can see the type of polyhedras be here in what chromium oxygen, yttrium oxygen, and you can check the expected or not expected. Then click here the file, the new structure, then click the new structure, that window will open. Phase already you can write here orthorhombic. Then the next is unit cell. Here select the orthorhombic. These all things be regarding my sample. You can choose your according to your sample. These are the orthorhombic. Put the 62, that will comes out automatically. Put the refined values of lattice parameters A, B, C. Then select the new one. The one row will be comes out be here. You can increase the rows by clicking the new. Suppose here the first row yttrium. Select here in the symbol. If you click the symbol, the periodic table will open. Select the yttrium and put the charge and put the x, y, z value, occupancy and thermal factor. Thermal factor should be less than 1. If it will be goes more than 1, it means you can choose the anisotropy. I would like to thank Mr. Rajesh Kotoj, who tell me about this software first time. Then I will give an sorry, one more things. This is a PPT presentation only. Then I will to give a demo to run this software.
people who have class can leave, or any questions you can ask.
Yes, actually I will tell those things. It's very important. Those are maybe you didn't get here. Okay, you can ask in the letter. Suppose I will start from the exactly starting. You have an XRD data. this the one software is expert high score. Just click or in, you can go in the file and then the option open and put your XRD data be here. The data will be appearing here, then check it's pure or not. So, I will go to check, the right click, select the search peak. The option is search peak, then accept. The peak list will be generated with full width half maxima, all things be here, 2 theta, brackets, D spacing, and go to the reference pattern. Not, sorry, it's not free, I think. And go to the restriction, select your material like Y, CR, oxygen, and then OK. Then check the quality, mostly star, calculated, modeled, Rietveld, and skip that things. Those are be non-ambient, okay. Then the pattern list. The pattern list will be comes out here. Then see which score is be matched higher, like here 84, 82, but this is a pure function phi CRO3. The deviation can comes out from instrumental to instrumental. So, I will check these things only. Then analyze, and I will see the position is almost be same here, and I will check the all peaks here, it's matched or not. Then I will open this reference code by double clicking. Here the space group is mentioned PNME and number is 62 already mentioned here. All details is here, and in the last lecture Professor Vishwas already told, if you change the target material from copper to cobalt or something else of different wavelength, then you should to check with a different wavelength also. Then click here the wavelength and take others and put the wavelength according to your requirement. Then the 2 theta will change according to Bragg's law, 2d sin theta is equal to n lambda. It should be remember, because it's be mentioned for here only for copper. If you will be okay from here, then I will go for refinement. Yes sir?
Okay means what, sir? Okay from here.
Okay. Okay means bahar aa gaya.
No, plus you see a good match, so you know that this is the structure. Now I have to refine this.
Yes.
Your first guess, like yesterday, Professor Garg mentioned, no, that if you
No,
are
I told कि I have an information my material is pure phase. yeah, it depends upon the range also. The database is for the 120, or I did the 20 to 80. This mismatch will comes out maybe from that cause.
We can use this full proof only after
After taking the assurance, you have in a your material is be pure, or you can do also for impure. It will be. I would like to mention here. You can use be simultaneously 16 phases with full proof, or one by one I will tell.
this software expert is not freely available. Is there any alternate software which is available?
I don't know, but most probably I use these things
If you are using Bruker has their own software, isn't it?
for refinement purpose.
For analysis, what you have performed.
Expert high score.
Yeah.
See, this is like if you buy something, if you buy a diffractometer, by default it should come with
By default it will comes.
this software and the data.
Not all the institutes have this spectrometer, but still people are using XRD by getting XRD
Data. Then it becomes a little.
Actually, they are boring and cracking.
So cracks are
Yeah, cracks are available not, but students can do.
This is getting recorded and we will put on this. Diplomatic etiquette,
Okay, now I will start the refinement. Okay. The first of all, make the date file. This is the format. I started from the 20 to 75, and the XRD data shows this is comes out from 20.01 to 74.99 with the step size 0.02, and the intensity ratio is be in columns. This is the DAT format, and if you starting, then put as like, then go to file, save as, and then here dot det as like, and then save.
I think you have to remove .txt to all files.
Hmm?
You also need to download that document.
No, if I will say, no, it will comes, but I will show to you how to save. I already have date file ना, तो dot det करके इसको सेव कर लेंगे. Now this is the foolproof software, and a lot of information in the manual. If you are free, you can check here. All are in PDF format, and check for updates. It's always be something new. Then click the ADPCR to start the refinement. Then click the new. Then all will be highlighted. I will not generate a new data here because it will take a lot of time. I will start directly whatever I take here. So file, open, then go to the source point I have on desktop. This, then open. Then you will start from the journal. You put the sample name as you mention in the date file. Something is important, the name folder. Then go to the pattern, date file and date shape, file format. I browse the date file here, pattern simulation as you mentioned. It have an option molybdenum, silver, cobalt, nickel, all. And if you don't know like synchrotron radiation, you just put the user defined, put the wavelength, since synchrotron radiation have an only one wavelength. So, you put the lambda 2 is 0 and I2 by I1 is 0. You also can choose the lambda 1 lambda 2 equally and I2 by I1 will be 1. Then pattern calculation, pseudo white. It also have a lot of option here. It depends according to your requirement. I choose here pseudo white is a combination of Lorentzian and Gaussian. 2 theta minimum I put here, maximum step size. Background I told 6 coefficient polynomial. Suppose you are doing with some substrate you do not want to include in your refinement. So, this is the one option to exclude this portion. Click 1 if you want to exclude one region only, put the lower angle and put the higher angle, means the shape ends point of the angle. If you want to exclude 2, 3, 4, 5, you can do be here. It will not include in the refinement. Then OK.
So I have a question.
Yes, sir.
Like if I have a two-phase,
If you have a two phase and you are really interested to do the fitting, so I already told you can fix simultaneously 16 phases.
16,
Yes, with full proof.
it will be so complicated, right? So what is a good strategy? Like let's stick to.
I will show the 3 phases.
Okay, 3 phases. Okay, let's.
Now the phases orthorhombic, crystal model. It have a lot of things here. It also be used for neutron diffracted data, and you also calculate the magnetic moment also here. As somebody are also interested in lattice parameter, not atomic position. So, for those pupils select this option, profile matching with constant scale factor. It will take less time in comparison to the now running here. It can take half an hour. Then contribution to pattern, pseudo white, X-rays, symmetry I already told. Then refinement, I took the 5 cycle least square approach used here and 6 coefficient polynomial. Here all are be checked, but you should to refine one by one, then refine the lattice parameters, scale, and then come back be here and take the combination of all and take the combination overall. Here profile, lattice parameters refined, UVW you can see all are be less than 1, eta and x also less than 1, and the B, this is the overall B factor. Atomic position, B factor, occupancy. If B factor will goes more than 1, so you can check the anisotropy, and 2 more option is also here. And then finally refine the 2 theta. There are only one possibility that can have some errors, because wavelength is fixed. Then OK. Now save the data. If you will click the save the data, the window will open and it will ask where you want to save the data. Just go to the same folder where you save your DAT file. It is very important here. And then click these things to refinement. The refinement will start, and you can run be here times to time, and you should be assured the background should be less to less, as you can as you can do as possible. Then it will be asked yes or no. If you think the refinement is okay, then put the yes, otherwise no. So, yes means the refinement, whatever we refined, it will be saved. And now I am be sure my refinement is okay. Then I will go for the structure, and I would like to mention here one more thing. In software is included one more thing, is a crystallographic calculator. Sorry, it is not opening, but you can also check the atomic positions here also with just putting the space group. Then after refinement, your window will appear as like, you can see as like, and you want to see your profile. I think it is not. Actually, most of times I am not using this thing. Its icon is directly appear here. It just shows the refined pattern, but I will try here, because the output file be generated from here. I would like to show you how to save the data. Yes, the data will appear as like here. So, the next thing, you want to save this data, then go to the file, save the data as multi-column file, click, that will ask, then OK, then it will ask where you want, then save. Yes,
इसका red color का ये
red is your data, black,
and that is standard data I think.
yeah, red is your observed data, black is modulated or calculated, you can say.
And that green is
Green is a break positions,
from and what is this
blue is the difference between the observed and modulated or calculated, you can say. Okay. And then that file will be appear here, it is directly open in the origin. Sorry, I borrow this from someone, I do not know where is the origin. Yes, okay. Then just open that file here. Because most of times problem, you did the refinement, but you do not know how to extract the data. Okay. that column will appear as like this is x, this is y, this is select x, this is y, select also x, this is y, select x, because this is a xy column, and just draw. Okay. The red one is standard experimental value, the black one is merged here. It's you can, it's your practice, just check the symbols and all things, and the difference is also be here. I think nobody having a problem here. Okay. Yes.
Can refinement be done in origin itself?
No, just you can plot here. Now the structure in Vesta. The Vesta software is going to open. Okay. I will going to upload my file here, or I will show this step by step. Okay. Don't forget the picture. Oh, sorry, forget the picture.
No, but it's beautiful.
Oh no, it will keep in your mind, but before that it will how it comes. Put the structure name here, unit cell. It's a new version software.
It is same look like crystal maker. So
I don't know, I didn't see. Then check the, select the here orthorhombic as in as a requirement of my sample, space group PNMA here, and it will automatically select. Lattice parameter, put A, B, C here,
this lattice parameter will
refined values.
but means the 5.5143 means is it so precise?
Not precise, but you whatever you got in the refinement, it will the structure will generate according to that. If you will decrease the number here from the decimal, it will be generate, but from that number. If you are ready to accept these things, then okay. If you are not ready, then put these values. Because here you just going to generate your picture, and after that bond length, bond angle always comes. You can be minimize the number be there. Then the structural parameters is also here. Suppose I want to, as is highlighted here, symbol, the periodic table will open. Choose your symbol be here, and this x, y, z you should to need put here. Occupancy, B factor also be 1 by 1 as you got in the refinement. And just clicking the OK, the structure will comes out be here. Not as like polyhedra will not appear here. If you want to see the polyhedra, I would like to tell, if you want to write, then write this step. Then the option is bonds. You should to know what is the bond between, like here, between the chromium oxygen and yttrium oxygen. But you don't know, so you will give some expected values for first nearest neighbor. Or suppose you can't expect, so you just increase the number. Like here, I want whatever you put in the database, yttrium, chromium, oxygen will comes out here also, and what respective you want to the bond length or bond angle, just select here. Like I select here chromium or oxygen, the minimum take 0 and maximum I do not know, I put 1 here. Okay. Suppose I delete it and put new, or I want to just chromium or oxygen, minimum maximum is put it 2, okay, and apply. You can see the polyhedra will disappear, but I want, then I will increase 0.2, apply, does not come. Do not put randomly 2 to 5, 10, 11, bond length are not that much, 2.5, okay, check the polyhedra, it is appeared. It is not exactly the 2.5, then click this, select and just click on the polyhedra. It will gives an information here. This is the respective information you gave the software, and after clicking it gives the bond between the chromium oxygen, it is a 1.97501. As respective, if you want to check the yttrium oxygen case, the yttrium oxygen and put like 2, not does not appear, 2.5, it is appeared. Okay, I will this polyhedra is be completed or not, you just to check. By rotating this thing, it is not completed, it is be half. So, you just to increase the bond length, as you can by practice you can see. So, I will show here the chromium oxygen and thus click this polyhedra, that will gives all information regarding your chromium oxygen polyhedra. What is the distance between the chromium O2, chromium O1? What is the average bond length between the chromium oxygen? What is the polyhedra volume? What is the distortion index? What is the effective coordination number? Bond length variation, and what is the fraction of Q, as like it is all mentioned in the manual. You can see what is the importance of what factor, and if you want to check the bond angle, so it is not visualized for me. So, I will disappear this polyhedra, or I will to see the angle between the chromium and oxygen. Just this tricone, click and click the 3 times, select chromium, oxygen and chromium. The angle will appear be here 146.5083. Select the another one, chromium, O1, chromium. it is 144.7452. As you can calculate the bond angle, if you want to especially the bond length, then click this button and click the any two, like this chromium and like this oxygen. It will gives a information only the single bond length, and whatever you did still now, the all information be mentioned in the below, and I want to save these things, file and save output text, any name you can choose. It will be asked for save or not. If you will save, it will be comes out as like if you will open next time. Then you can increase the size or decrease, zoom out and zoom in here. You can be in ballistic model. In ball, it's according to your ionic size with polyhedra, wire, sticky nature. Okay, and if you don't want to put the name be here, just remove the labeling, nothing will appear. If you will click, then it will appear. If you want to see the rotation, then just click, it will be moved automatically. It is in your hand at what direction, x axis, sorry, A direction, B direction or C direction, yeah, anti. It's all.
It's a good tool we can use even for teaching, isn't it? Just to
Yes,
show,
sir.
like, on those lines, I have a very stupid question. If I want to just highlight, say, the interstitial sites,
Hmm.
can I do that? If at all, it's a digression from you are talking about very high level thing. I'm asking a very simple question. That if I want to show an octahedral site,
Yes,
simple
sir.
FCC, I would work on oxide structures like you and the other Ashish. Like if there is an octahedral structure and I want to show that the coordination.
Okay.
For our undergrads.
Yes, it's a very good thing. Whatever I accept from you, sir, it's correct or not, you can, sir, tell me. Suppose the structure is, sorry, structure is here, and I just want, what happened, free rotation, and I just want to see one polyhedra here. Then you can go here, the boundaries, and just it's a manually, you just check and just check, it comes out.
This is an octahedron, isn't it?
Yes, sir.
Oh, okay, good.
I will check it comes out or.
I'm just thinking this may attract our undergrad students.
Yes, sir. It's actually hand to hand, sir. It's
Learn this.
a single polyhedra will appear, sir, but it's on practice, sir.
But like, yeah, it can be done.
Yes, it comes.
It can be done.
It will just show
It's very easy to visualize, like.
and just remove the don't show of this, and it will be appear single polyhedra, and just animate it. You can rotate these things.
It's a good visualization.
Yes, sir. And it's in your hand. You can move it like as. Yes. Yes, reciprocals. But don't be confused, just for visualization here. Still no any confusion?
But can we replace some atom by some other atom?
Yes.
Can we replace oxygen atom to a nitrogen atom?
It's just a layered structure, whatever you give the software, respect to your lattice parameter atomic position. It's and it will just gives the bond, bond length, bond angles, and nothing it can do in Vista software.
In other software we can do that.
I don't have an idea. Whatever I know, I would like to share here. Then can I go for next?
Is it open?
It's free. No need to install also. So I am going to next step. This is a 3-phase refinement. I will start directly the PCR file. General will be same. Before that, you should to collect your det file. Pattern will be same for all phases. There was nothing change here. It's all be parameters same as previously I told. Then the next is phase. As the users told, I have a 2-phase, 3-phase, multi-phase. Then first clicking the 1 times, it will be singly appeared. I put the orthorhombic structure YCRO3. Basically, it's a synchrotron high pressure study, and it have a YCRO3 material, tungsten, gold. So I need to refine all 3 parameters, and since I already told this is a synchrotron, so this is only one wavelength, user defined, put the one single wavelength, lambda 2 I put the 0, I 2 by I 1 is 0.
A bit of digression, but why how can you get tungsten and gold here?
Tungsten means actually this is the material that induce this with ruby, it will create a pressure.
Okay, so it's like a diamond and
Anvil cell, sir. Yes, sir.
So there comes tungsten.
Yes, sir.
And
Gold.
Gold also there. So
It's a jelly type. It will be used.
okay.
Yes.
So tungsten is like more like a gasket from
Gasket, yes, sir.
And gold is where your powder is mixed.
Yeah,
and
it
you
will
apply
put it
pressure.
outside.
Okay.
Then phase. First, put all things be as like previous. Symmetry of I already told PNMA. Okay. The next, for next phase, put add. Then it will appear a one more window. So I will go to the next, or I already filled here, cubic, and this refinement is on with constant scale factor. Atomic position will not appear here, and put the symmetry of that material. And then third is also cubic. For tungsten, I am minus 3 m. Minus 3 you should to write as like here. And then OK. Yes. Okay. Then go to the refinement. The 3 phase will appear here, 1, 2, and then 3. The best trick is to refine one by one, and sometimes no need to refine all the parameters at a time. In the last also, it will be complicated sometimes, but you should to refine the parameters in a combination. I am not telling the refine all the 3 phases at a time. So I started be here from the first phase, the raw material. Background I refined and then unchecked. It's be refined one by one, taken a combination, and then the full, and then as previous I told, the A, B, C, U, V, W, eta x, I did all things be same. But here I did the unchecked except atomic positions. Then start the second one from the background. One by one I did, taken a combination, and then A, B, C, U, V, W, eta and x. One by one and taken a combination and then unchecked. Then start the phase 3, also be same, and did the uncheck all things and start to refinement. After OK, then saving and then start to refinement.
But here your life is easy because
Yeah.
nothing is going to happen to your gold and tungsten.
Actually, it's not excluded, sir.
No, but I mean, like, if you were to have a phase transformation in your material,
Actually, it comes out, sir, in the pattern.
so it will be difficult, right? Like,
Yeah, it's a
you know
diffi-
the pattern, but it will be difficult, isn't it?
Actually, a solution I don't have. Everybody is doing with phases, actually. Or actually, this measurement is not come be here. It's outside.
No, but that's why you need synchrotron. Because
Yes, sir.
Your wavelength is such nice that all the peaks will be spread out.
Yes, sir. So it took 1 month for one measurement. I will not hide anything. It takes a lot of time. Sometimes file crashes, sometimes something happening, and after 2 months. After 2 months, I got these things, and this is a pressure dependent measurement. It had 20 datas, so it took 6 months, 7 months.
See, the reason I'm asking, because these days all these X-ray companies,
Yes, sir.
they also have their, Rietveld refinement too.
Yes, sir.
And if you ask them, so nowadays they say that वो तो 5 minutes में हो जाएगा.
Hmm.
This is the language they use.
Yes, sir.
But I don't trust them, right? In 5 minutes,
नहीं होता है, sir. It's never
that's
be
what
happen.
they claim, but
If somebody is telling it comes out in the 5 minutes, they are not will tell about this UV, W, H, I, X parameter, because it will just shows this figure in the origin file. If a good teacher will be here, it will also be checked the students what is your UV, X, W I want to see. I would like to mention here the Professor Dhananjay Pandey is not trust to anybody. He just want to see what is your software I will see.
so ultimately what
And he is also telling it's not a 1 or 2 days work, it's a minimum 10 days to 1 year.
So the reason is, all these softwares are so costly.
Yes, sir.
And people have this ability of, like foolproof, you showed you are running from one window to another window.
Yes, sir.
You have to take the effort to learn this. And these softwares, obviously, since the company people are developing, they are very user friendly. You click a button and it gives an answer.
Yes, sir.
And many people tend to believe as if
In
this is
in
correct.
expert high score you can do, but I didn't get the option to use the multi-phase.
So, but it doesn't work. It's
Yes,
not
sir.
good. It's not just with one particular company that I'm saying.
Yes, sir.
With every company claims that you use our software and pay us few thousand dollars or euros, but it doesn't work. And foolproof is all but free.
Foolproof is free.
So
Or I met this person, he is very friendly.
it's only in academia probably that you can get something for free.
Yes,
Good
sir.
thing for free.
Yeah, in 2013 in BHU he came. I think he is the friend of Professor Dhananjay Pandey.
Yeah, it means he and even Professor Rajiv Ranjan in ISC,
Yes,
they
sir.
use foolproof.
Yes, sir.
So no one buys all these fancy software.
I think Professor Rajiv Ranjan is also the student of Dhananjay Pandey. Yes, sir.
So I mean, like, people, the reason I'm asking, because even for texture,
Yes, sir.
earlier we used to buy software worth lakhs of rupees, Now we use a freeware.
Yes, sir.
Okay,
It's a totally free here.
free, yeah.
And suppose somebody don't want to use the click. So for those people, the software is like for commanding. The window will appear as here, and you can control be here also, but it needs a practice. Because Grewal sir is doing from here. He is not like to click. And this is the all things.
Okay, so I think let us thank Ashish for a wonderful job. This software is available for free, and generally means the way I'm saying, because there are plenty of things like for texture also. I'll show you, there are now even for EBSC data analysis and all. We our first impression is, you know, the way we think about the world is of something is free means, you know, kuch gadbad hai. But at least in academic field, you know, we are not here for making money. So all the softwares which come for free are actually good. And I'm sure you must have said that there will be a user group here.
Yes, sir.
So if you have any query, you can also share on the user group. If you have a doubt, write it down and I'll tell you these guys will get back to you.
Actually, I met to that person, Professor J.H. Grejwal. He is telling I can be, मतलब ये paid कर सकते थे इसको, but in Spain, oh sorry, in France, is not a culture.
It's not a culture, yeah. Same to what we have. ज्ञान बांटने से बढ़ता है.
हाँ, मतलब उनका यही था.
Same culture. So
और he expand the salaries also be in some cultural activities.
right.
And he is too friendly nature.
No, that's what. So we have to learn humility also, you know. So scientific thing is, you know, scientists have to be humble also.
Yes,
So with this, I think all of us agree that, you know, Ashish gave us a very nice glimpse of ritual refinement. So let us give him a round of applause. And on behalf of organizers, I will hand over a small token of appreciation for you, Ashish.
Thank you, sir.
Thanks a lot for a nice talk.
Yes, sir.
Yeah, we should shake hands also.
Yes.